afternoon, everyone. Welcome to our C2 Smart sponsored Connected Vehicle Roundtable. This is the last in a series of events that we've been hosting around connected vehicle technologies, hosted here by C2 Smart, which we are a Tier 1 USDOT University Transportation Center and very active in the research world of connected vehicles and in its deployments. So we're very excited today to be joined by five fantastic speakers and active technologists in the connected vehicle world. We are joined by Sisinnio Concas, who is Program Director of the Autonomous and Connected Mobility Evaluation at University of South Florida. Mohammed Talas, who I mistakenly identified as Deputy Director, but he is Director of ITS System Engineering at New York City Department of Transportation. William Billy Chup, who is Data Analyst and Engineer at Volpe National Transportation Center. Carl Wunderlich, who's the Director of Surface Transportation Systems at Nobilis, and Khan Asbey, who many of you might have heard from last week, who is Professor at NYU and Director of C2 Smart Center. So we're going to be talking with our distinguished panelists over the next hour about connected vehicle technology. And after they give a brief intro and some discussion on their roles, we're definitely going to have extended time for questions and comments from the audience. So please use the Q&A button at the bottom of your screen if you want to lodge a question. And if you have a comment that you'd like to even speak out loud, feel free to use the raise hand button and we'll call on you for our panelists. So, and as a reminder, this panel is being recorded and will be shared on C2 Smart's YouTube channel shortly after the event and distributed for those who can't make it today and want to join. So without further ado, I'm going to introduce our moderator for today's event. Our moderator is Jinchin Jani Gao, who is a Senior Research Associate at C2 Smart at NYU and very experienced in leading connected vehicle technology studies over the last several years. So with that, Jenny, take it away.
Thank you, Sri. I'm super honored and excited today to be the moderator of this roundtable, and it's really great to see everyone again. So I'm pretty sure most of the audience know about the USDOT Connected Vehicle CV Pilot Program, but in case you don't know, just give a little bit of context. The USDOT CVPD seeks to spur innovation among the early adopters of connected vehicle application. It's sought to test V2V applications, V2I vehicle to infrastructure applications to improve mobility and safety with real-world deployment in 3 cities that include New York City, Tampa, and Wyoming. And this roundtable discussion will focus on these recently completed pilots and all the lessons learned that we have gained from those deployments. And we will hear from 5 featured panelists, as Sri introduced. They're kind of cover practitioners, decision makers, and also researchers involved in the CV deployment and leading the way for their wide-scale adoption. So before we start the discussion, I would like to hand things to each of the panelists to just give us a little bit context on maybe who you are, what you do, and what is your involvement with CV pilot or technology. Maybe let's start with, I'm going to just read from the list order from my Zoom screen. Maybe let's start from Billy.
Hi, my name is Billy Chup. I've worked at the Department of Transportation's Volpe Transportation Systems Center for the past 7 years or so. I'm a data analyst and engineer here. Most of my work is in just sort of the general data analysis space. I work a lot in air quality and environmental work, as well as the connected vehicle and autonomous vehicle space. On this particular project, I was sort of the technical lead on the independent evaluation effort at Volpe, trying to analyze the safety impacts of all 3 of the pilot sites. So I was pretty hands-on in all of the data coming out of the pilot sites that were being run by some of my other panel members here. So some of the things we were looking at were developing ingestion pipelines, pre-processing algorithms for all of the connected vehicle data, looking at statistical analysis, and safety impacts from those resulting data sets, specifically looking at driver responses to the in-vehicle warnings that were being deployed.
Thank you, Billy. Dr. Osby.
Hi. First of all, I'm kind of host here, and the others are guests, so it's virtually. So thank you for coming and accepting our invitation. I'm going to be very brief, and actually today I'm going to try to talk not much and hear from the others. So I'm a professor at NYU Civil and Urban Engineering Department, and I'm a director of the C2 Smart University Transportation Center. And it was a great pleasure to be part of this New York City CV pilot test, mainly thanks to Mohammed Talas and his colleagues' efforts. We had a great project. We really learned a lot, and hopefully now we'll be able to publish what we learned in terms of papers. And I'm looking forward to hearing from the rest of the panel.
Thank you, Dr. Osby. Dr. Talas, do you want to go next?
Yeah, thanks for C2 Smart to host this seminar and inviting me and others as well. I have been dealing with ITS project management and traffic management for a while in the city for New York City DOT. And I became the program manager and project manager for the connected vehicle in 2016 to last year, end of last year. Again, my experience was focused on traffic management, so the mobility incident management and all the traffic safety issues that result of impact on our roadway network was always a concern and has to be analyzed. When we got involved in the CV pilot, our focus was to support Vision Zero, to improve safety, and to use the CV technology as additional tool to advance traveler safety. I believe we have concluded with this project with very good result on all the what was developed and has been tested and produced in the field. So thank you again.
Thank you. I'm pretty sure Billy knows that because he did the independent evaluation of all the three CV sites as well. Sisinnio, do you want to go next?
Yeah, sure. Thank you. I'm so excited to see again many of my colleagues probably we spent close to 5 years together assessing one way or the other these very interesting 3 CV pilot deployments. Each one of these pilots is different in that the goals of each pilot were meant to tackle specific mobility and safety issues in different urban and non-urban environments. So this is really a unique deployment for which, for example, in the case of Tampa, the focus was on tackling mobility and safety issues of commuters, just real people driving on their way to work. And the role that I had as director of the Autonomous Connected Mobility Evaluation Group was to be the task evaluation lead for the performance measurement evaluation. There is the very first step in the CV pilot deployment that entailed multiple roles. The very first one was the collection of primary data coming from the CV technologies, specifically from the roadside units, and there are many data elements of relevance for both research and evaluation purposes. And the ensuring at the same time, in our specific instance, the privacy retention of the participants, because we had more than 1,000 individuals participating in the study with the other part of the technology, which is the so-called onboard units and their own vehicles, and pipelining the data, in this case, back to USDOT, and here our colleague Billy processing and analyzing the information for the scope of the independent evaluation. And altogether, as being a research center where we operate, that provided a tremendous opportunity to also do some other spin-off type of research on human behavior, because we're talking about the deployment of vehicle-to-vehicle and vehicle-to-infrastructure applications. So the safety component and how people respond as they're exposed to these technologies is paramount to understanding the benefits. And in the very end, the basic and very relevant questions of the USDOT, what are the benefits of the CV technology? What happens once you start scaling up these at the national level? And I think each one of us has a very important role here. There's Billy, but also you will hear from Carl, because they are really close to the upper chain at the USDOT when it comes down to policy decision-making purposes, and eventually using this formation for future rule-making purposes. So I'm down on the data analytics side. I'm really excited to learn more from my colleagues as we talk about, what's in front of us as it pertains to the future of this technology.
Thank you, Sisinnio. And Carl, sorry, you're the first to, who came, but somehow it shows on the last on my list.
Oh, last name starts with W. You're used to going last. It's no big deal. It's used to it forever. Good afternoon, everybody. My name is Carl Wunderlich. I work for a company called Nobles. I'm sitting today in beautiful Gaithersburg, Maryland, just outside the Washington, D.C. area. As Sisinnio mentioned, Nobles and as our part for the CV Pilots program, we were the technical support contractor. And in fact, my involvement personally with CV Pilots started in 2014, when the first idea about trying to do a connected vehicle pilot deployment program first began to circulate within the USDOT headquarters building. What I can say about that era was that such a decision to move to deployment, to sort of step away from the kinds of R&D projects on test tracks or controlled environments, simulation studies, and the kinds of things that had been done prior in the connected vehicle sphere on USDOT, that there was really a question about whether or not these technologies were ready for deployment. And so I think after doing a little research, and I think that a relatively courageous decision was made on our part of our clients to push forward. And so I think what we may have forgotten or may have lost the times, because we have so many happy guys here sitting and talking about the success of the program, was that in 2014, 2015, it looked like a relatively high risk activity to take on, to try and put some of these technologies in play with real people and real environments, real commuters. In the case with Sisinnio down in Tampa, real freight operators, truck drivers, and law enforcement and other state officials or state personnel in the state of Wyoming along I-80, and real life, honest to goodness people living and doing their regular work in both Brooklyn and in Manhattan, including a number of the folks who are on the call today. Anyway, so but maybe sort of forgotten in the midst of time was that this was actually really hard to do. And I think everybody that's on the call will tell you that the technology, while good enough to work, and these guys on the call right now, all three sites did a tremendous job in really advancing and maturing those technologies to make them deployable, practical, useful, and to generate the data that in the end Sisinnio and Billy and others were able to utilize to demonstrate the benefits and also some of the difficulties of doing connected vehicle deployment for real, with real people in live traffic environments. So I'm happy to be here as our technical support contract role also is wrapping up soon, but we have produced a number of lessons learned documents that are available on the Connected Vehicle Pilot Deployment website, which includes, I think, pretty much something from everybody that's on the panel there today. You can see the many publications that came out of this particular project, the wealth of information that could be shared. So that's me, Jane. Back to you.
Thank you, Carl. So thank you all so much to give us some brief idea of what you're doing, what is your involvement with CV. And I'm going to start just throwing out some questions to kick off the conversation. But, we're definitely going to cover some of the things that Carl, you guys already mentioned, the barriers. We all know that it is not that easy to actually lead to the final success of these deployment. But feel free to jump in if you have anything specific to highlight. So the first question I have is, We know each pilot site focused on different use cases, right? Wyoming was testing travel information messages. Tampa and New York City both tested various, V2V, V2I, and pad apps. And based on the performance evaluation and the mobility safety benefits you see from the deployment, what role do you think the connected vehicle have in the immediate future? So we're not talking about the long term, just in the immediate future, what kind of role do you think that CV can add? Anyone want to jump in first?
I can jump Jenny, on this one. From New York City pilot experience and perspective, again, safety improvement that can be produced by connected vehicle, but those V2V and V2I application is already realized. We see that in all the new vehicles, some of those applications, how benefit forward collision warning, which is maybe an AV application. But imagine with this technology that we have, an aftermarket safety device that can be deployed in an existing vehicle, a used vehicle, not a brand new vehicle, that can cost $500–600 and can be populated right away. If there is a decision and there is a standard is adopted, the world has, my understanding, about 1.3 billion vehicles. So if we wait basically for all the new vehicle production, we will not be able to see something tangible as we like to see. Initially, USDOT, my understanding, has stated that 80% of the 5 million incident crashes that happen in the United States can be addressable by connected vehicle, okay, by all those safety applications. And probably the saving is, my understanding at that time, was projected to be $500 billion anyway, if those. So if we can achieve 50% of that, ideal situation, that would be great. But the main things here is, it's doable if we focus on the safety benefit, on the aftermarket, on the solution that addresses both new vehicle and used vehicle here, and we can see results right away, definitely.
I saw Sisinnio trying to say something. Go ahead.
Yes, in terms of the promises of the technology, in terms of solving real world issues, I think each one of the pilots has demonstrated that the technology can contribute in different ways. I think there's also a third pilot of relevance, which was recently completed. It's in the state of Wyoming, studying the impact on adverse weather conditions. And in the case of Tampa, again, we were focusing on specific issues because ultimately, in our case, the grant recipient from the USDOT was the Tampa Expressway Authority, which is a very innovative limited access roadway that cuts in the core of this very fast growing urban area. So when the authorities here received the grant, one of many of the goals that they were trying to achieve were related to mobility and safety issues in this very fast growing downtown, which is the city of Tampa here in Florida. And it was very difficult to think of in terms of how, for example, CV technology can contribute towards reducing congestion, given the fact that no matter the scale of the deployment, which was much larger compared to some of the previous, call it experiment or sort of endeavors that Carl mentioned earlier on a few years back before the CV pilot deployments, we were able to see that with the penetration of roughly 7–8%, depending on the hours of the day, because of our experimental design, keeping in mind that, again, we were trying to recruit participants, commuters flowing into the downtown Tampa area. using this facility and tackling one of the use cases specifically in this instance was to try to reduce the queue formation in a specific section of this roadway by utilizing vehicle to infrastructure applications, and at the same time developing and also providing V2V solutions like the forward collision warning application that Mohammed was just mentioning. So we're trying to assess to what extent the deployment of V2V and V2I were effective. While throughout the main phases of the pilot, specifically towards phase 2 and phase 3, which were really operation and demonstration of the efficacy of these technologies, we were able to utilize the data coming from the vehicle to show that in the very end, as it pertains to our case, the vehicle to infrastructure applications are very relevant. And two of them, in our case, the speed harmonization application. So trying to provide information to the travelers that with the hope that if many of them would eventually abide to the speed advisory, we would be able to tame congestion issues. And the second one was a wrong way entry. Actually, the third one had to do with multimodal transport, because we were tackling vulnerable road user issues by deploying the so-called pedestrian collision warning applications. So we were able to see that vehicle to infrastructure applications in the realm of CV technologies, they're really promising. The V2V, although we were able to prove, as Mohammed said, the impact on safety, a lot has to be said in terms of the state of maturity and the constraints of the technology itself towards assessing the efficacy of the V as it pertains to V2V. And I think Billy can expand upon that, being the dependent evaluator and the rest of the team. So a lot of lessons learned, and we know now where the pros and cons are in terms of when we start talking about V2V and vehicle to infrastructure applications.
Yeah, I mean, I'll add that. I'll say like one of the most interesting things to analyze about the data that we got out of the connected vehicle pilot programs was the applications that are really only possible with V2I technology, V2V or V2I technologies. I think both Tampa and New York had applications that the group that I was working with at Volpe, we've been analyzing in-vehicle driver warnings for 20, 30 years at this point, just from sort of LiDAR, radar detection type stuff. But being able to deploy applications like red light violation warnings that rely on SPAT communications, signal phasing and timing communications from the infrastructure, or speed warnings or wrong way entry warnings that kind of use vehicle locations and information from the infrastructure to issue these kinds of driver alerts. Those were the most interesting because it was so new. It was something that was only really possible with these kind of this kind of communication scheme between all the different players in the transportation system. So that, I think, in terms of the role that CVs have in the immediate future, there's, like Sisinnio said, there's constraints and there's a lot of lessons learned that are pretty well documented at this point. But in terms of where the technology can really shine, I think is kind of where we've learned a lot about what is possible without with this kind of technology, and that's kind of where I think the focus should be going forward.
Yeah, I think both Tampa and NYC are kind of the role model, I would say, that prove that large deployment of CV and also like deploying CV at a complex urban area is possible and can bring some safety benefits. And I know both, Sisinnio and Billy, you mentioned that there's vast amount of lessons, also Cars, and I think you also mentioned that there's vast amount of lessons learned from the CV pilot, and they're not just about technology, right? There's also, takeaways from coordination, partnership, data collection, and evaluation. So I guess my second question is, what lessons learned from the pilot should engineers, policymakers take from these deployments? And are there any barriers you see, for full adoption of CV technology? And I think this time, I want to hear from Carl first. Carl, if you have any insight or thoughts about maybe from the high level, from the policy, from the coordination level, and what kind of lessons learned and what you see for the future adoption of CV.
Right. So I think the top USDOT realization or value, the thing that was really driven home from CV pilots was the importance and value of interoperability and how that just doesn't happen for free, right? So in this particular case, just to back up in case folks are not interoperability fans out there, we asked the 3 different sites to start working on CV technologies. There's a lot of coordination among the teams, but there are the set of standards for all that equipment to work together seamlessly. We're not in a mature form, primarily because, as I said before, such a large-scale deployment, 3 concurrent large-scale deployments had never been attempted before. So one of the things that was really built into the research plan and into the deployment plan from the USDOT perspective was an emphasis on trying to actually show that interoperability could be done. And again, back in 2014 or 2015, such a thing, it wasn't just a foregone conclusion that it would happen. And the events of 2016 to 2020, including the large interoperability test, which we were able to mount in 2018, where we actually, the equipment from all 3 sites, the roadside equipment and the OBUs, the onboard units for the cars, in all 3 sites, we brought them together in McLean, Virginia at the Turner Fairbank Research Center. And in a multi-day, very well-structured and difficult test, showed that all that equipment can work together. It didn't work, by accident. That's the other thing I'll throw out there, is that part of it was USDOT emphasis on it, a ton of technical support from us and other folks, but as well the commitment on the part of the 3 pilot teams to actually do this as a goal, and to make it work was a huge achievement. I think to some degree we can hang our hats on that, because in addition to all the other benefits, it has demonstrated that it is possible to do so. And 100% interoperability, 115% interoperability may not really be relevant, but the idea that messages sent from a vehicle that had been started as part of the Wyoming deployment could be in Tampa and communicate with an RSU for a roadside unit for a particular kind of purpose, maybe different from what it had been envisioned in Wyoming, but still be able to conduct and do that. And likewise, a similar situation with any of the vehicles or equipment in New York. So that I think was a real positive for connected vehicles as a technology as a whole, to note that for it to really roll out at scale, if the idea is that Tampa vehicles only work in Tampa and equipment from Tampa only works in Tampa, and there's no sharing information, they're not interoperable when they move to other sites, would really limit the potential of CV to do something significant at scale. And I think CV pilots, number 1, showed that it can be done. It's not easy, but it can be done, and it's worth it and from a policy perspective, to me, that feels like the number 1 lesson learned from the pilots, is that interoperability is not a distant dream, but a realizable and practical near-term capability.
I totally agree, because I think, transferability and scalability are really, really important through all these 3, CV pilot. And also, what I heard is that there's also a lot of shadow deployers that are kind of following, what Tampa is doing, Wyoming is doing, New York City is doing, and testing the testing CV technology in their own site. So there's definitely a lot of transferable lessons can be adopted at other places.
Yeah, these guys were so popular that the technical meetings that they were having to work among themselves to do the kinds of things we're talking about, prepare for evaluation, interoperability, that people just wanted to be in the room to sort of hear what was happening, and it became almost distracting for the teams trying to do that. So the USDOT formed a cohort model of other early deployers who were interested in CV technology to kind of follow along, and we as tech support for USDOT and some of our other colleagues funneled information in sort of an easier way than just lurking in the back of the room for these technical discussions, so they could get the benefit of it. And in fact, that cohort is still ongoing as part of the USDOT activities. It may not be quite as active now because the CV pilots is wrapped up, but it's still an active group and shows the influence that these 3 sites had on the overall industry.
That's great to hear.
Jenny,
Yeah.
let me add like a couple of things. I mean, one is, so I've been doing field tests for almost 25 years, and they're difficult. It's very difficult to do field tests, and New York, I think, was really an example of extreme difficulty because it was such a big field test. So, I think that was, and I'm familiar with that. That's why I'm mentioning it. But any field test is very difficult, but also very useful because you can learn much more from a field test than doing simulation only kind of study. The other thing is obviously in all these things, there were human subjects involved. And whenever you have human subjects, you have additional difficulty because due to privacy, IRB, all those issues. And actually, we probably struggled for a couple of years. I mean, in the beginning of the project, to iron out those issues with human subjects and so on. So anybody who's planning, so that's the lessons learned. You know, if you're going to have a large field test with human subjects, have additional time to deal with that. I think the one thing that I learned in this one is that, you know, when you're talking about a new technology like CV or even autonomous vehicles, AVs, the technology providers can also have a difficulty because they might go, you know, they might be bought by another company, they might go bankrupt, they might not be able to deliver what they do because these are not, everything is not known, you know, you know, there's this thing like that, unknown unknowns. So, so we have to be really careful about that and plan again accordingly. And one of the, for example, things that happened, and I mean, Carl and Mohammed can comment on that. I think towards the end of the CV pilot, the SRC was no more a dedicated communication channel. So it just kind of changed everything in terms of future, not for the CV pilot, but you know, so things change in a technology way. So I think those lessons can be used moving forward, not only with CV, but also like AVs, for example. So if you're going to do like a large scale AV test somewhere, I think these lessons that we learn in the CV pilot can be very useful to kind of, you know, have a smoother AV pilot or maybe more advanced CV pilot. So, and that's, those are like my few takeaways.
Yeah, I like to add just a clarity on the policy role here, very critical. The changes that has happened was based on the FCC, the federal government, a change in the band of the communication. And if we need to have a firm future deployment, we have to have a firm standard and guideline and leadership from the federal government directing both the OEM and the stakeholders and the local government and everyone on the same architectural framework that is designed, and they can advance accordingly. Otherwise, you will see, you will not see, you know, cohesive and uniform deployment from one zone to another. That is very critical, you know, and we have experienced that. The second issue is the market penetration is dependent on the users at the end. Who is going to pay for this additional technology? We have to have buy-in from those motorists. So we needed more outreach to the level of the motorists about the importance of the technology and the benefit of the technology. And in a way that I come back and I say, you know, aftermarket safety device for a few $100s, you can introduce that additional safety rather than several $1,000s in a different sales of a new vehicle. So focusing on our motorists and getting their buy-in here, the public into the program is very important, and the outreach in that level is very critical, because we dealt here in New York City with 3,000 vehicles, And those 3,000 vehicles were agency, city-owned fleets. Despite that, it's owned by the city and we are the fleet manager, it was not easy to make that coordination and to attract all agency to participate and bring their vehicles. So imagine when you go outside, I believe in Tampa, they did some different program to participate. So we have to keep an eye on, how we're going to do this in the future, if it is on a large scale deployment or a major change and a trend.
So one of the lessons learned from the first 3 phases of the pilot, to tie up with what Mohammed was just saying in terms of the willingness to pay to have this technology adopted at the very end by the users. When we approached the phase 3, we were working with some of the technology that were installed as aftermarket devices installed on vehicle stock of a certain age. So participants that saw some relevant value by installing this added technology to their vehicles. Some of the cars did not have in-vehicle sensors like you would expect if you were to buy a 2022 car that has all the features and it can help you out. So it really provided some value added. And one of the main lessons learned came from not only just the direct analysis of the data generated from the technology itself, from the onboard units, but also running several surveys of the participants themselves. And this was part of a process that was at stake in terms of some of the requirements for the performance measurement evaluation and the coordination, say, with through Noblis via Carl, in terms of making sure that what we had in all the documentations leading, during the planning phases to the implementation then of phase 3 would sort of make sure that we would capture the information. So we gathered a lot of lessons learned by surveying the participants, and we had a before and after assessment of their perception about the utility of the technology. And after being exposed through the CV technology, at the very end, more than 2/3 of the 1,000 participants that we had in our study, they saw a lot of value coming from the CV technology, with nuances, of course, because they were exposed to different applications, the different V2V and V2I. And that led us to some lessons learned at the end of phase 3, where we saw some opportunity then to move on to, okay, what happens if we move on in terms of the type of technology, the small startups or small companies developing the so-called onboard units, those devices in the cars, to more commercial grade type of onboard units. And thanks to SIA, the Tampa CV Expressway Authority, we were able to engage OEMs. So we had the participation of Toyota, Hyundai in a subsequent phase of the pilot, where we had a different set of technology installed in there. And some of the information that we were able to gather from the participants was exactly on the willingness to pay for this technology. And they gave us a very good ballpark of what a typical user might be willing to pay to have the technology installed as a retrofitted technology in their vehicles, because that gave good information actually back to the OEMs as a feedback as they move forward. And once the issues they clear up in terms of the regulations, we heard about the SRC and CV2X and so forth. Once that clears up, there's information that has been gathered through this deployment that is also useful for those that are making cars and thinking about, what's the return of having this technology in their vehicles. And I think that was one of the biggest lessons learned in terms of getting a good sense of the willingness to pay for the technology that gave good information back to, in this case, to the OEMs as they're planning and deciding, how to enter on a very large scale in terms of having this technology in your car, just you that are driving to work.
Thank you, Sisinnio. I think I've been hearing, a lot of great lessons learned, from end user buying, outreach efforts, not only to end users, but also to show what are the actual benefits that we get from the pilot, policy side, technology side, field test. I think I want to come back to one of the things that both Dr. Talas and Dr. Osbey kind of mentioned on, some of the CV technology, they have a mix or they can be be used for like automated vehicles, autonomous vehicles as well, right? So how do you see the integration of CV technology and automated vehicles? And since, I don't know, Dr. Asby, since you mentioned that, do you want to first maybe add your comments to this question?
I think there are like two school of thoughts. Like one is AVs should be completely on their own. It's almost like a individual robots, and they shouldn't be talking to each other. And we shouldn't worry about that. Not they shouldn't be, but we shouldn't worry about that. So they could do great stuff on their own. The other school of thought on the other hand is like, yeah, AV is good, but they should be talking to each other and coordinate and so on. Obviously, there's some middle way. I'm more of a middle way person, so I believe that you will have both, but the best way probably if most of them they can talk to each other, exchange information, which is not a very difficult technology, and it will improve their safety, their operations if we have AVs doing that. So in that sense, the CV pilot and CV related project will be useful because we are learning about communication problems, we're learning about how drivers behave and so on. So you can take these lessons learned directly if we have AV pilots, but AVs are completely different in many ways because especially talking about level 4, level 5, I mean, no driver, they're doing things on their own. So there are things we can use from the CV tests and CV pilots, but there's a lot of things we cannot. So we need to kind of do this AV pilots on their own. So that would be my kind of, again, my thinking. But again, sometimes the most trivial looking technology is very difficult. Like making GPS work in New York City was a big challenge because of high buildings and so on. So now you're talking about a different level of difficulty with AVs. So in a way, some of the lessons learned are not like very pleasant. We learned that these things, when you deploy them in real world, they become big challenge due to real world complications like tall buildings, and then GPS not working 100%. So I think we should be careful not to jump to conclusions. And these pilots can teach us that kind of very like a basic information too.
I like to add that the autonomous vehicle requirement, it's pending today for regulation and policy. It requires an ideal or close to the ideal roadway infrastructure, clear marking, signage, and others, in addition to the challenges. So as we see those requirements that are needed for autonomous vehicle, we believe, the autonomous vehicle program will be, until we have that perfect zone constructed, the autonomous vehicle penetration is going to be pushed more to the future. Okay, until we have all the perfect situation and environment suitable for that operation. However, we could do that, part-time in a certain zone and confined lane, other than just a general zone. However, the CV is deployable now. We could do it now. Okay, so the way I see it, if we add the CV, if we merge that with the autonomous vehicle, it will accelerate even the autonomous vehicle further programs. We will make it more safer as well. On the other hand, there is a V2I communication and I2V communication that is necessary, and there is multiple safety application that are required, and even the SPAT message and the map message that need to be sent back to the vehicle. So those are information from the infrastructure. So the autonomous vehicle alone will not be able, if it's not connected will not be able to get that information of the roadway ahead of that vehicle from the map message or even from the SPAT message. So that also, I would believe, it's a missing part in autonomous vehicle. And if it's not implemented, if it's not connected, it's going to make it also more difficult to be implemented.
Not to, well, to draw out on that a little bit more, I think the effect that connected vehicle technology can have on autonomous vehicle deployment and penetration is different in the different pilot sites in these different environments, right? I think Mohammed got to the point that, in order to pure autonomous vehicle deployment kind of is relying right now on these perfect environments, lane markings and clear signage and all that. But when those exist with more frequency out on, I-80 in Wyoming, it's a lot easier to sort of have a driverless car on a relatively open highway. And the operation of that autonomous vehicle might be helped a lot more by the traveler information messages and those the spot weather impact warnings and stuff that were deployed in the Wyoming pilot. And so the effects can kind of vary in these different environments. And there might, you might accelerate the penetration of autonomous vehicles in different ways. So that all should be kind of taken into account.
I think I see a lot of, uncertainty, but also opportunity, for this integration of CV technology and automated autonomous vehicle. So just a quick announcement for the audience. If you have any questions for the panelists, please select the Q&A button at the bottom of the screen and type any questions you might have. And I guess before we go to the question, actually we got one. So this is a question from Chuanshu. He is asking, what should academicians do to support deployment, CV deployment, I guess. And I think I would direct this question to Dr. Asbin and Sisinnio, because, basically they're asking, what do you think from the academia that, for the research side, what we can do to support the CV deployment in the future?
I think the big question is, how do we prove safety? And I talked about buying in from the public. And the bottom line here is KPI, performance measure. And what do I expect of safety? So you have simulation of the several dozens of safety application or mobility application improvement that can be simulated, that can be studied, improve and benefit to cost analysis of the program. That is a major undertaking research that can be very useful in if the academia focus on that. And it's definitely useful for, again, the policymaker to make their decision, to make their case, and also the public to have a buy-in in the program, showing the safety benefit in terms of monetary sometimes or saving lives as well. So traffic simulation studies and work and program and labs that shows those improvement, as well as further performance measure, financial benefit to cost studies also will be very useful.
I just wanted to point out that a good portion of the data that came out of all three of the connected vehicle pilot programs is publicly accessible on USDOT's public data hub. And if anyone's listening in or has anyone in their network that's interested in looking into that data, it kind of varies between the sites what's available, but and it's kind of provided under a USDOT doesn't have any sort of liability on any sort of accuracy and stuff. There's disclaimers there, but it's all available on USDOT's data.transportation.gov website. And, we'd be very interested in seeing academics look into that, download it, get some statisticians involved. Like Mohammed said, that safety is a really key thing, and getting more of those key performance parameters, showing different results from what we did on the Volpe side, on the independent analysis side. We invite people to kind of recreate our analysis steps and look at the benefits of these technologies outside of what we did.
I think, these are excellent points. And actually, what I have to add very quickly is that academicians, and this is, following to Billy's point, academicians might have a different perspective. So the moment the data is publicly available, we can look at the data from different perspectives and with different tools that you would do as an engineer, as a consulting company, or as a agency, because your needs and questions that you want to answer might be different. So I think as academicians, the way we are trying to do it, look at it from a relatively different perspectives, take some risks, ask open-ended questions, and then see how this data and this test can be used to advance the state of the art. So go beyond the questions that we generally answer in an engineering study. I think in that sense, this is what we have to do. We have to be more kind of risk-taking in terms of looking at the data and using different methods. But of course, to do that, we need to participate in these studies. And a lot of the academicians are not interested in doing that because these studies are difficult, time-consuming, and sometimes you don't get any results. So we should be open-minded about that too, because the rewards are great. You learn a lot from these studies.
Maybe to chime in a little bit, it's because the question is related to, what can we do to support deployments in general, or this type of endeavor. So what we have observed, that at least might be a bit biased, of course, because it's coming from an academician here, is that, what kind of a support an academic institution can provide to, for example, a local agency or just an entity that is looking at the opportunity of partnering, say, with the USDOT and thinking about developing this as a solution to improve mobility and safety issues for their own community. The academicians, they need to be stakeholders, because very often the agencies, they don't have the analytical capabilities or the backbone in there. They rely on cooperation and cooperation between academic institutions in terms of providing the analytical capabilities. Like in our case, we're continuing, as the pilot ended, the Tampa Bay Expressway Authority still achieved the goal of being in full operation and maintenance of the system. That was one of the major goals of USDOT, have a sustaining infrastructure, because it's not just you put a roadside unit there and then the game is over and you have a bunch of boxes hanging on poles. That is not the case. You need to continue to find the best way to cost efficiently sustain this infrastructure. So one of the greatest aspect of having a civil infrastructure in place is that for these agencies, they can retain a very high level of kind of call it ownership of the information or the data. We're not talking about the privacy issues related to participants or people driving on the network, rather information that, first of all, it's a very high frequency information that by itself has a lot of value for both safety and mobility assessment. But the role of the academic institutions is to be something in between, being a stakeholder and providing that backbone of analyzing the data coming from the technology, and better advise or be there to advise the agencies how to move forward in a cost-efficient manner in the future as they embrace these technologies. So I think it's research, but also be there as a local partner.
Since I think we're 5 minutes away from 5, I'm gonna just ask for short reply for the rest of the questions. But I got a harsh one from the audience. So Hagai was asking, what aspect of CV are you most skeptical about? Sorry.
Yeah, maybe I'll go first, Jenny, because it's related to actually the third question. So I
Right.
think it's not necessarily the CD technology I'm skeptical of. It's just what I think is the largest misperception on the part of actually folks who are involved in ITS deployments, that they expect the GPS to be extremely accurate, right? Accurate in ways that are actually not proven in the field. Now, I think, Mohammed and the New York City team, as Khan alluded to, did a great job solving one of those problems related to the urban canyon. But I'd say in general, GPS is not as accurate as people think, even engineers think, and that makes assumptions about what kind of things can be deployed in CV more difficult, honestly. So realism around GPS accuracy, I think, is a nice piece. And I think another plug for why infrastructure is helpful for Cs, CAVs, CVs of all types is that they can help to resolve some of that. And so since there are only short answers, I'll just stop right there. So I answered 2 questions, 1 short answer.
Yeah, if we talk about the GPS issues, our team can talk more than like a week on that. All the issues that we have experienced with the pad app, and the solution that we're trying to provide. So I guess if nobody gonna add to that, I'm gonna just ask about the last question, which is from Saz from NYC DOT. So Saz is asking, where do things stand with the DSRC determination? What other alternatives are now being considered?
Yeah, again, we have completed the project last year. This year is under evaluation with all the data. 13 billion file and records were produced and sent to USDOT. Volby is involved. We have experienced basically the situation that has resulted from the FCC reallocation, and we are in a situation of looking for migration right now to a different technology. But again, we are looking for federal government leadership in setting forward the framework and the standard that we have to move on. There is opportunity now. There is CV2X, a lot of program and initiative and grant is going, so that's excellent. But also 5G on the positive side, as it is designed to perform, will introduce better result in the future when it is fully deployed. It's going to provide the peer-to-peer communication, vehicle to vehicle, without going to the cloud. It will provide another layer, lower layer than the cell tower of communication that can be used for triangulation as ultra-bound communication and triangulation, and provide much better vehicle location identification, adding and correcting the GPS XY coordinate. We have tested that, okay, but it was expensive to deploy. But now with the 5G, the future is going to be definitely better. That's my opinion, and that's how I conclude myself.
All right. I think we're about at the time. So I wanted to thank you all so much. This is super insightful conversation. Sisinnio, Dr. Talas, Billy, Carl, and Dr. Osprey, thank you for your expertise and time. And before we go, I would like to know, if you want to say anything or share any final thoughts, I would really like to give that opportunity. Otherwise, I will welcome.
I want to thank everybody for being here. Thank you.
It's great to be on the reunion show. That's what I'll say.
Yes.
We talked about it a little bit
I
beforehand.
agree.
I miss these guys. I haven't seen them for a little while. So, if we're going to do a 10-year retrospective, and sign me up for 2032, Janie. Okay, I'll probably still be around. I'll show up.
I was going to say, as the federal representative, I'll let the guys up there know that we need direction on the DSRC standard.
That would be
Please
great.
join us at the TRB. There's a lot of output that's
Yeah.
coming from the CV pilot research. We really look forward because there's a lot of more than the lessons learned, but there's additional research that has been conducted on V2V and V2I apps.
I think good to see you all today, and I like to wish you a very good and nice holiday season. And we look forward for that 10 years meeting. Hopefully we will meet.
That's
Yeah.
right.
Not there.
Muhammad and Khan, they may have to wheel us out. Billy and Sisinnio, they'll still be, doing high jumps and stuff, but they have to wheel us out for onto stage of the 10-year reunion. But yeah, great to see you guys. Great to be invited. Thank you, Khan. Thank you, NYU, for putting this on.
Thank you, everyone.
Okay,
Thank you
great.
very
Thank you,
much.
everyone. Thank you for attending today's roundtable discussion.